For regular videos on ancient cultures and forgotten civilizations, please subscribe. If you would like to support the channel and become part of our ancient history fan community, visit patreon.com/World of Antiquity. In my last two videos, Ancient High Technology and Ancient Advanced Machining, I looked into videos made by the UnchartedX channel, which laid out a case that many of the stone artifacts that have been found in Egypt were made not by the Egyptians, but instead by a civilization from thousands of years before, which was wiped out by a cataclysm. This third and final video in the series will address the arguments UnchartedX makes in the video, Precision, Evidence of Ancient High Technology. I say final video, but if UnchartedX is open to engagement and in good faith responds to this series of videos, and I hope he will, I may make another one. We'll see. But now, what about precision? And why is it something the ancient Egyptians could not achieve? Let's find out. The UnchartedX channel is run by Ben Van Kerkwyk, and I have been told that his channel offers some of the best evidence for the existence of a world-spanning advanced civilization during the Stone Age that ultimately was destroyed by a comet impact. That's why I'm engaging with his videos, and I want him to know that although, at the time of recording this audio, I have not been convinced by his evidence, I did approach his material with an open mind and was willing to be persuaded by rational argument, and to accept whatever good point he may have made. I hope he will watch my video with similar deference. His video is over an hour long and I can't play back everything he says, but I am making an effort to address all of his main points, and I will leave a link to his video below so that you can go check up on me to see that I didn't take anything out of context.
In this video, we're going to look at another category of evidence for ancient high technology, the one that I think is the most convincing, that of precision.
If you were as disappointed as I was in the evidence that UnchartedX provided in his machining video, these words may offer some hope that what we will get in this video will be significantly more convincing.
The nature of precision bears some explanation, as while it's a word we all know and hear pretty frequently, it certainly gets used constantly as a marketing term, precision this or precision that.
This is a good point. Precision is a subjective term, after all. And he will eventually get to his explanation. But first, he goes on an excursus, first talking about how important precision is, which is basically filler because it's irrelevant to the argument, and then going into how precision, or at least the type of precision that he's talking about, was apparently unknown or unused in ancient times. That part is relevant and worth exploring, but he doesn't actually tell us anywhere in the video how precise something has to be in order to be considered out of the capability range of the ancient Egyptians. How can we make a proper assessment if we don't know the dividing line between possible and impossible?
I recently read a book called The Perfectionists: How Precision Engineers Created the Modern World, written by Simon Winchester. It was recommended to me by Philip Adams in a brief email discussing the precision of the Serapeum. In this book, Winchester describes the rise of the modern pursuit of precision, beginning with its origins in the 18th century in England with the birth of accurate chronometers and developments in cannon manufacturing for the Navy, and also in the progression of the steam piston engine. Our civilization progressed from measuring precision in units of tenths of inches in the 1700s, right down to the nanotechnology of today that can be measured by the diameter of individual atoms.
Despite what he has said about the level of technological advancement of the purported lost civilization that he's arguing for, nothing he says puts it on the level of nanotechnology. So it would seem that our modern society is more advanced in precision than the lost civilization he proposes. Am I reading you right, Ben? Please correct me if I'm not.
Why did we do this? Why did we go to all of the trouble, expense, and effort to develop and keep pushing back the boundaries of precision? This question may seem obvious, but it reveals one of the fundamental aspects of precision, and that is its relationship to function. We develop these expensive capabilities because they gain us notable functional benefits in their application. Inventing the capability to create hard surfaces that are perfectly flat to within 1/20th the width of a human hair is a difficult and expensive thing to do. Developing the capability to even measure such precision is equally expensive, if not more so. It requires calibration, and none of it comes naturally to us. You can't see this level of precision with your eye. You can't feel it with your hand. You need sophisticated, calibrated, and expensive metrology instruments in order to do so. We simply don't create precision manufacturing capability to this level for any other reason than function. We don't develop it for ceremonial purposes, nor do we develop it for artistic reasons. However, once we have this type of precision manufacturing capability, it can be applied to all sorts of end products.
The idea that precision is necessitated by function is an important part of his argument, and specifically he means mechanical function. But here is where his argument confuses me. He says that precision in manufacturing is never developed for ceremonial or artistic purposes. But he says that after it's developed, it can be applied to pretty much anything we want, including artwork. If that's the case, then an object for artistic use can be made using precision manufacturing, right? But then why later in the video does he use precision to argue that archaeologists are wrong to say that precise objects had a ceremonial or artistic purpose? Ben, could you explain?
Overall, I enjoyed Simon Winchester's book, as it certainly makes the case for precision forming the backbone of the modern world. One thing that I mildly disagreed with was the notion that the concept and practice of precision only began in the 18th century. I think it would be more accurate to say instead that the practice was restarted in the 18th century, or that the concept was only rediscovered at that time by modern man, as it seems clear that at some point, ancient man had a pretty damn good grip on the concept and application of precision as well.
I agree with Ben here that ancient people had a good grip on the concept and application of precision. Where we differ is that he denies this capability to any ancient civilization that existed since 6,000 years ago, and I grant them this capability. If you've done any research on ancient Egyptian mathematics, you will know that they calculated complex geometrical problems with precision, and even were able to calculate pi accurately to within 2 decimal points. Now, of course, I realize it's one thing to be precise on papyrus, and another to be able to create it in stone. But my point here is that the ancient Egyptians in general had a good grip on the concept and application of precision.
Although this isn't something that you will often see or hear discussed by orthodox archaeologists, there is tremendous evidence for very high degrees of precision in many of the vastly ancient stone objects and architecture all around the world. Some of these objects display a level of precision that simply could not have been accidental, and by its very nature required sophisticated tools and highly advanced knowledge and capability in order to achieve. Although we find neither sophisticated tools in the archaeological record, nor any records of advanced capability in what we know of ancient civilizations, the proof that both existed at some point in the past is incontrovertible.
Does anyone know specifically what he means when he says sophisticated tools? In the last video on machining, he seemed to mean electrically powered or fuel-powered tools, although he is careful not to be nailed down on that point. But here he means tools that can cut very precisely, which of course don't need to be power tools. From what I've seen, many ancient tools were sophisticated enough to cut precisely. But again, precision is a relative term, isn't it? We can't make a decent judgment until we get to the examples and are provided with the measurements. And of course, it doesn't matter how sophisticated your tool is. If you have an idiot using it, the finished product is going to be crap. And that goes for power tools too. So now let's look at UnchartedX's first example, the sarcophagi, or as he calls them, megalithic boxes, in the Serapeum of Saqqara.
Perhaps the best example of measured ancient precision is found in a place that I've talked about extensively on this channel, the Serapeum of Saqqara. In terms of smoking gun evidence for ancient high technology, this underground labyrinth and its 24 huge megalithic boxes is really at the top of the list. The precision of these mighty single-piece boxes and their lids, some of which weigh up to 100 tons, is measured in straight lines, in flat surfaces, and in the perfect squareness of corners and relative faces.
But he won't be providing the measurements of all of them, because, unfortunately, their measurements are unlikely to fit his thesis, since a large number of them have visibly unhoned sides. He will be providing the measurements of only 2, and the measurements are nowhere near complete or comprehensive even on those 2. Sorry, I don't mean to make fun, but why are you coming to us with partial data?
Using a calibrated and expensive precision straight edge, manufacturing engineer Chris Dunn has measured the inside surfaces of a couple of these boxes to be precisely and absolutely flat, to within 1/20th the width of a human hair, or 0.0001 inches, which is the limit of his straight edge. Wherever he moved the straight edge over the flat, mirror-like interior walls of the box, light did not pass underneath it, which it would have if the surface was not perfectly flat.
Some of you may have caught a problem with what UnchartedX just said. Dunn measured the surfaces with a straight edge that was accurate to 0.0001 inches. And from this, UnchartedX concluded that because Dunn couldn't see any light pass under the straight edge when he placed it on the surface, therefore, the surface must have been accurate to 0.0001 inches. He assumed the precision of the tool was equal to the precision of the surface. That could only be the case if the level of precision of the tool is visible to the human eye. Can the human eye accurately perceive up to 0.0001 inches? I don't think so. Yes, you can use the straight edge to measure the flatness of a surface, and if you shine light underneath it and you see the light come through, you know it's not flat. But if you don't see the light come through, that doesn't guarantee that the surface is as flat as the straight edge is. No matter how precise the calibration of the straight edge, using your own eye to measure can only be as precise as your vision. Dunn, as it turns out, used that straight edge to measure only 2 sarcophagi in 1995, and Dunn says it was accurate to 0.0002 inches, half as accurate as what UnchartedX says. Dunn admitted that it wasn't a proper scientific analysis because it was done hastily, saying, I quote, "I wished at that time that I had the proper equipment to scan the entire surface and ascertain the full scope of the work," unquote. Fortunately for us, an independent research group called the Isida Project visited the Serapeum in 2012 and 2013 to take measurements and photos. I'll leave a link to their website below. The YouTube channel Sacred Geometry Decoded did an excellent overview of their evidence, and that's how I learned about this group. I will also leave a link to his video below, which is excellent and goes into more detail than I will here. Now let me show you photos that were taken when a straight edge was used by the Isida Project on the sarcophagi. Do you see any gaps here? How about here? I think we can all agree there are gaps. These surfaces are not perfectly flat, and even the human eye can see that.
Using a precision square, calibrated to within 5/100,000ths of an inch, or 0.00005 inches, he found the inside faces of the boxes to not only be perfectly square and parallel to each other, but also perfectly square relative to the lid. This is a profound achievement.
Did you notice how he worded that? Using a precision square calibrated to 0.00005 inches, he found the inside faces to be perfectly square. The measurement he provides is not the measurement of the object. Again, it's only the calibration of the tool. He doesn't say how square the inside faces are, just that they're perfectly square. Whatever that is in numbers is anybody's guess. Dunn measured more methodically in 2001 than he did in 1995, but he did it on only one sarcophagus. He doesn't say which one, but it looks to me like sarcophagus number 23, I think. It's unclear whether this is a third sarcophagus done measured or one of the same ones he measured before. But considering that there are 25 sarcophagi, measuring 2 or 3 is not going to give us a decent assessment of the overall quality of the entire group. I'm happy to report that the Isida Project took a precision square to the site and took measurement of the angles on 2 more sarcophagi, sarcophagus 17 and sarcophagus 25. The square is accurate to under 0.5 degrees. Are these perfect 90-degree angles? I think you will agree, even within the margin of error, no.
Now, not only was this done perfectly for one box, it appears to be a feat repeated time and time again across many of these boxes.
Look, you can't make such a statement if you don't have the measurements of many boxes. So, where do matters stand? Well, we have some incomplete measurements taken by Chris Dunn, which according to his word indicate perfect flatness and perfect angles in perhaps 2 or 3 sarcophagi, and we have incomplete measurements taken by the Isida Project on several more sarcophagi, which indicate imperfect flatness and imperfect angles. And we have the photos to confirm. So how convinced are you at this point that these boxes are all perfectly precise? Even if Dunn's measurements indicated perfection, which they do not, perfect plus imperfect equals imperfect.
Nobody does this kind of work unless there is a very high purpose for the artifact. Even the concept of this type of precision does not occur to an artisan unless there is no other means of accomplishing what the artifact is intended to do.
Imagine walking into a church with Ben, and you both see a large cross with very precise form, super straight edges, the crossbar at a precise 90-degree angle. And let's assume you and he have absolutely no knowledge of Christianity or crosses. And Ben turned to you and said, "Nobody does this kind of work unless there's a very high purpose for the artifact. It must have had another function originally." One of the churchgoers would look at him like he was nuts. "It does have a very high purpose," they would say. You see, Ben is judging work by his own standards, not by the standards of the people who made it. What he thinks is a high purpose, someone else might not, and vice versa. For the Egyptians, these sarcophagi were made for a high purpose. Precision can be and has been, time and time again throughout history, used to make ceremonial objects.
The only other reason that such precision would be created in an object would be that the tools that are used to create it are so precise that they are incapable of producing anything less than precision. With either scenario, we are looking at a higher civilization in prehistory than what is currently accepted. To me, the implications are staggering. This is why I believe that these artifacts that I have measured in Egypt are the smoking gun that proves, without a shadow of a doubt, that a higher civilization than what we have been taught existed in ancient Egypt. The evidence is cut into the stone.
The problem is that artifacts of the same precision as these boxes, even greater precision actually, are well documented throughout pre-modern human history.
The Serapeum boxes are also, at least to my knowledge, the only boxes that have been measured and tested, at least to some degree, for aspects of high precision. That analysis was done by Christopher Dunn on his own initiative, and even then was only performed on a couple of the boxes in the Serapeum and not on all of them. While many of the other precision boxes seem to have very similar characteristics to those in the Serapeum, I can't find any evidence that they've ever been tested this way, even by the relatively rudimentary testing that you can do with handheld precision straight edges, squares, and corner radius dies. I think this fact speaks volumes about the motives of the academics and the institutions that control the access to and the research funding for sites and artifacts like these. They just don't seem to be that interested.
Yeah, I admit the subject kind of puts me to sleep too. But here's the thing. If you're going to argue against the mainstream view and present a case for an alternative view, you can't base your argument on evidence that you don't have. First, you obtain sufficient evidence, then you present it. Now hey, if you want to call for an investigation, do that. But evidence you don't possess cannot be used as a basis of belief. The most you could say is, I think it's possible that these boxes are all precise to within 1/1000th of an inch, or whatever. You can't reasonably draw further conclusions in the absence of evidence.
It's worth noting that when you look at the various boxes in Egypt, there is also strong evidence for multiple levels of technological capability. Although they're always uniformly labelled as sarcophagi, whether it's for people or for bulls, there always seems to be two types of boxes. There are the precision-made ones with straight lines, sharp corners, flat and polished surfaces, and then there are the clearly handmade boxes, which are imperfectly done and still display chisel and hammer dressing marks. Although this isn't always the case, in general, the poor quality boxes tend to come from the later periods, with the precision boxes being attributed to the older and earlier periods.
When UnchartedX speaks of earlier and later periods, he's going by the dating that archaeologists have given the artifacts. So he appears to agree with them about the relative dating, what is earlier and what is later. So I have a question for Ben. Why do you subscribe to the relative dating of archaeologists, but not to their absolute dating? What makes the relative dating correct, in your opinion? Anyway, UnchartedX admits that it isn't always the case where the finer boxes precede the cruder boxes in time. But what he doesn't seem to know is that the finest boxes of the earlier periods are inferior in quality to the finest boxes of the later periods. While there will always be outlying examples, there very clearly is a progression of technology over time. Here is one of the most beautiful sarcophagi of the Old Kingdom period. And here is one from the Serapeum from more than a millennium later. Which do you think is better made? How about this one? Also from the later period. Is it artistically inferior or superior, would you say? There definitely was a progression of technology over time with the better quality boxes from the later periods, not the earlier periods, as Ben asserts.
Even the oldest box known, an 8-ton single piece of granite that is under Mastaba 17 at Maidum, appears to be a precision-made box, and it's not something that's been roughly carved by hand.
Appears to be precision-made? Is it or isn't it? What are the measurements? No argument can stand on speculation, but compare it to this box from the Serapeum, and I think anyone can see which is better made.
Here at the site of Tanis, you have the two types of boxes actually lined up side by side. One is clearly precision made, and the other is obviously not. They reflect vastly different levels of capability and technology, and only one of these matches what we know about the tools and techniques of the dynastic Egyptians.
How is anyone able to judge the truth of what you're saying if your sole evidence is video or a photo? You said earlier that the human eye cannot judge the sort of precision that you're talking about, which you explicitly compared to our modern precision.
You can't see this level of precision with your eye. You can't feel it with your hand. You need sophisticated, calibrated, and expensive metrology instruments in order to do so.
Remember that? So if the ancient tech you're talking about was as precise or almost as precise as our modern tech, why are you appealing to the human eye now?
The fact is that it wasn't until after we had begun our own modern voyage down the path of precision that we even had the capability to notice and accurately measure ancient forms of precision, or to even appreciate the sophistication of the manufacturing techniques that were required to achieve it. This evidence has been sitting in front of humanity for thousands of years, like some sort of coded message sent down through time, but it's one that we've only relatively recently developed the capability to read.
So far, we haven't seen any solid evidence of precision up to even 1/100th of an inch. And of course, if you think that precision up to 1/100th of an inch was not discoverable until recent times, you're simply not familiar with the evidence. But maybe his next example will show greater precision. Let's see.
Found in the tens of thousands, these vases and objects are today mostly associated with the very earliest periods of ancient Egypt, even the first and second dynasties, as well as the archaic and pre-dynastic periods, which is a huge clue right there, as these periods are quite literally considered part of the Stone Age. The range of shapes and materials used in the manufacture of these jars and vases is both wide and varied. Some are tiny, almost as if their makers were teasing us with their capability, and some are quite large, but they all seem to display a frankly astonishing degree of symmetry and precision. This jar is one of my favourites, and it seems to have been so precisely made and so well balanced that it can stand upright on its tiny base, almost like an egg standing up on its tip.
I'm impressed. Those ancient Egyptians had some excellent craftspeople. But you know, it did take them some time to get it right. The earliest stone vases in Egypt come from the Merimda culture of the Neolithic period, and they are rather basic in design. After a few hundred years, the quality improves, as can be seen in pre-dynastic examples. Then, in the early dynastic and Old Kingdom periods, we see the industry producing very fine work. So it's clear that there was a gradual improvement over time, just as we would expect. In other words, the fine examples don't appear out of nowhere. These vases were made out of many different types of stone and will continue to be made throughout Egyptian history, though granite was popular mainly between 3500 and 2200 BCE, and then again during the Second Intermediate period. What was in fashion changed over time, so the shapes of the vessels can be used to date them. Sir Flinders Petrie, in fact, pioneered this method of dating.
Many jars seem to be made this way, and while I've not had the privilege of handling them directly in order to test this, I'd like to see anyone try and make these by hand with copper chisels and the known techniques of ancient Egypt. All I can say is good luck.
Copper or stone chisels would only have been used at the beginning of the process, such as we see in examples now at the Petrie Museum, which show you vases only roughly shaped and never finished. The next step would have been to use a coring drill, and here you can see an example, also in the Petrie Museum, of a circle in red paint that was used to mark the spot where the drill was to be used. The interior of the vases was bored out using a forked wooden drill shaft with a stone borer attached. Examples of stone borers can also be seen at the Petrie Museum. It's all there for you to see. I will leave a link to the chapter in mechanical engineer Dennis Stock's book, Experiments in Egyptian Archaeology, in which he documents all the evidence for this, and also his experiments to confirm that this process works. If you want to see a demonstration of a stone vessel made by hand, you need look no farther than the YouTube channel Scientists Against Myths, where it has been demonstrated how the vases may have been made, and with very simple technology at that. The materials they used were wood, sandstone, corundum, hemp string, alabaster, and quartz. They used a grinding and drilling machine, a bow drill, a chambering tool, which is a grindstone on a wooden handle, and, while they used no copper chisels, they did use a copper saw and copper drills. The total work time was about 6 months. It's reasonable to suppose that with generations of experience and training, the experts of the Egyptian stone vase industry would have been able to cut that time down quite a bit. Isn't that beautiful? I recommend you go there to see the whole video.
While some vases or jars seem very solid, others are almost ridiculously thin, to the point of transparency, like these examples.
No. Egyptian alabaster is translucent, naturally.
In some cases, like this vase that has suffered some damage, we can get an idea of just how thin this material is. Shaping and carving out the inside angles and the inside cavities of these jars, some through very long and narrow necks, and then keeping the material thickness consistent and accurate is an extraordinarily difficult challenge when working in very hard stone.
He then goes on to quote Sir Flinders Petrie, who gives the measurements of the thinnest examples, one case with a neck 0.05 inches thick and a diorite bowl 0.024 inches thick. We're still not at 1/100th of an inch. If the process used in the Scientists Against Myths video was used, would it be possible to make the neck of the vase that thin? If the stone is hard, as it is in the case of granite and diorite, there is less chance of it breaking. Remember, we don't have to show that every time they made a vase it came out perfect, that every attempt to get that thin was successful, only that it was possible.
Working in these brittle and very hard materials, particularly to these tolerances, is a remarkable feat of manufacturing. From granite to diorite to schist, breccia, flint, conglomerate, quartz, basalt, and even obsidian. These small objects are typically made from some of the hardest and most difficult to work materials you can find. There is one vase that I know of that is made from corundum. And yes, this is corundum. There are several forms of it. It doesn't all look like gemstones. And corundum is a 9 on the Mohs scale of hardness. It's the hardest substance on Earth next to diamond. Supposedly these were all made by hand, with basic hand tools, flint or copper chisels.
Now you see, I was going to say that the harder stone was easier not to break, and therefore, with those types, the craftsperson would have greater success than if working with a softer, flakier stone. I'm still trying to figure out who told him they were made only with chisels.
Analysis of the stone itself reveals further challenges. Many stone types have vastly varying degrees of hardness in the material itself, being made up of conglomerate mixes of different individual chunks of various materials and crystals. As the piece is being worked, cutting edges would move from relatively soft material into very hard and brittle crystals that would typically shatter rather than cut cleanly when worked. Yet many of these vases are both mind-bendingly thin as well as being finished and polished to a very high level.
I'm not sure he knows what he's talking about here. The degree of difference between the softer and harder parts of stone in one of these stone vases is not nearly as drastic as he's making it out to be. Until he provides us with specific examples that illustrate his point, I think we can write this off as UnchartedX speculating.
The technology involved in making these jars is so far beyond clay pottery or ceramics that it's laughable to house them together and say, look, these all came from the same place, so they must have been made by the same people.
This argument is so strange and not really thought through. Let's set aside for a moment the very clear demonstration of the technology we saw in the Scientists Against Myths video, which was in keeping with what we know about ancient Egypt. Surely UnchartedX doesn't believe that in any given culture, all technology is the same. We have, in our own times, a huge variation in technology levels. Some people do it old school. Some people are on the cutting edge. Would we ever conclude that because people today make vases by hand, that our society could not also make them by machine? Or that because some might make a pot out of stone, others couldn't make a pot out of ceramics? His position necessitates a rejection of variation and variety.
Some of these jars were, undoubtedly, used as canopic vessels as part of ritual mummification. Why then were they sealed with rough mud and clay lids? These clay lids are still housed and displayed in the museum, right next to the incredible stone jars. Yet how can you say that these are equivalent technologies that came from the same people for a singular purpose?
UnchartedX argues that if they made stone pots, they should have made stone lids. Well, first of all, if these stone lids ever existed, why did the Egyptians not use them? There are only 3 possible answers. 1, because all the lids were somehow destroyed while the vases survived, which is too much of a coincidence to be realistic. 2, the Egyptians chose not to use the lids. And 3, there never were any lids. In both of the latter cases, which are less far-fetched than the first, the clay and mud sealings for the jars were preferable to the Egyptians. Why? Because in order to preserve the organic contents, the jars needed to be sealed, so mud had to be used either way, and a clay seal would have allowed for contraction and expansion without the lid coming unstuck.
From observing the markings of tube drills, which I've covered in detail in other videos, Flinders Petrie deduced that the ancients were familiar with rotating tools. But from analysing the vases and bowls, he realised that they were also familiar with turning the work itself. He concluded that they must have used something that's similar to a lathe, with features like mechanical tool rests, in order to manufacture these objects.
Indeed, a lapidary lathe and similar devices do not have to be high-speed or high-pressure tools. They only need enough pressure to cause abrasion between the grinding surface and the object being worked. The optimum pressure for lapidary cutting using a quartz abrasive is less than 1 kilogram per square centimeter. Tools that could do that might be an adaptation of a slow wheel, potter's wheel, or bow drill. The object being worked could be placed on pivots and hand-rotated, or the bow drill could be modified into a partial rotary pole lathe. Pole lathes are tools that rotate the object back and forth instead of spinning it. If a lathe were used by the ancient Egyptians, it could just be used as a finishing tool for fine dressing the vessel. All the rough shaping could be done by percussion and other types of lapidary techniques. The removal of the waste rock is less time-consuming that way.
Remember that according to mainstream academics today, the Old Kingdom Egyptians did not have access to the wheel or its principles, of which lathes are an advanced technique and still something in vastly widespread use today in workshops and manufacturing all over the place. They say this because there's no evidence for the wheel in their writings or in their diagrams, and according to most academics, they didn't have command of the wheel until the Second Intermediate Period, thousands of years after the Old Kingdom, around the time when the Hyksos invaders showed up with their wheeled chariots.
As I mentioned in my Ancient High Technology video, the Old Kingdom Egyptians were entirely familiar with the principle of the wheel. Their potters, for example, made clay pots on wheels. I don't mean the potters were on the wheels, I mean the pots. In fact, the first appearance of the potter's wheel is in Egyptian art. UnchartedX must have heard somewhere that the Egyptians didn't use wheeled vehicles and then concluded that they didn't know what a wheel was, even though all their neighbors whom they interacted with were using them.
No analysis of the objects in the museum would be complete without a mention of the notorious schist disc. This is a very complex artifact, labelled naturally as a jar or a vase, that was found amongst primitive flint knives and copper tools in the mastaba of Prince Sabu, a royal from the very first dynasty of the Old Kingdom. This does not seem to be the result of lathe work, but rather these complex curved surfaces have been precisely carved into very hard stone and then repeated accurately for each of its wings in these sweeping motions that the stone makes. It's a masterpiece of stonework, yet supposedly this was created in the very first dynasty of ancient Egypt as nothing more than ceremonial artwork.
I'm having a difficult time understanding the reasoning that because something is well made, it can't possibly have been used for ceremonial purposes. He hasn't even made a case for precision here. It's just so beautiful that it can't have been made for aesthetic purposes. Right? Does that make any sense to you? Nothing more than ceremonial artwork? Who would put any effort into that? If it's a masterpiece, it must have a mechanical, functional purpose. I'm sure it offends a number of artists to hear him say things like this.
Buckle up, because this is where it gets really interesting, as these massive objects take the evidence for advanced technology in vastly ancient times to a whole new level. I'm talking about the giant columns and the giant statues that are found across many sites, both up and down the length of ancient Egypt.
If he keeps going, there's not going to be anything Egyptian left.
In terms of pure symmetry and a demonstrated mastery of working in hard stone, the huge single-piece flared columns are really hard to beat. My favourite example is a remnant from this column, shaped from pink granite, found at the Old Kingdom site of the Temple of Bastet. It's hard to describe the stonework here as anything less than pure mastery. Consider that the original quarried block of stone must have been wider than the widest part of the flared end on the column, and then worked down to the width of the column body on a perfectly aligned centerline, then shaped and finished with accuracy and symmetry.
Beautiful, isn't it? Strange that he's looking at a temple that was made late in Egyptian history. People have been confused by this, because although there was a temple here during the Old Kingdom, that temple was destroyed. And the ruins that you see here are from a newer temple of Bastet constructed during the Third Intermediate Period, 9th century BCE. And by the way, palm leaf capitals like this one are found all over ancient Egypt, all throughout their history. It's part of standard Egyptian temple construction design.
The flares, angles, ridges, and curves on this piece all appear flawless. They are made entirely smooth and well polished, and the entire massive body seems to be utterly symmetrical and balanced. Was this made by hand, do you think, with pounding stones and copper chisels? I just can't imagine how.
Why are you asking us to use our imaginations in your video essay which purports to provide proof of ancient precision? For the purposes of this argument, what matters is not how precise it looks, but how precise it is.
To my mind, this must be the result of some very advanced tools, along with significant mechanical assistance and guidance. Once again, I think objects like this column would be a very easy target for a non-destructive analysis using modern metrology techniques and high-resolution 3D scanning. It wouldn't even be that expensive to do.
Okay, so if I got him right, he's saying that we all should believe this column is more precise than the Egyptians could have made before and until he or someone else can provide evidence that such is the case. Something is backwards.
Here at the Old Kingdom site of Tanis, you can see the same shaped column ends that we saw at Bastet, although they're more heavily eroded by time and weather. Some huge single pieces of multiple columns still remain here today for tourists to puzzle over. These seem to have been stamped out in ancient times as if they were made in some sort of giant factory. Dozens of these huge single-piece granite columns are known to exist, or have existed, and the ones from the same installation are all typically identical, and they all feature flared ends in palm or lotus shapes. They've all been found on the oldest of Egyptian sites, places like Bastet, Tanis, Saqqara, and Giza.
Ben hasn't done his research again. The oldest structures in Tanis, the oldest, are no earlier than the 21st dynasty. And the earliest reference to Tanis in any document is from the 19th dynasty. Do you know how many years after the Old Kingdom that is? 1,000. The only structure here that may have come from earlier is one containing material from Amenemhet I's reign. Now, because such material was clearly appropriated by New Kingdom pharaoh Meremta, and because Egyptian records say there was just a field here prior to the 19th dynasty, scholars have concluded that Meremta brought the Amenemhet material here. But even if you were to believe that the structure with the Amenemhet material in it comes from Amenemhet's time, that would still only make it as early as the Middle Kingdom. There are no buildings here from the Old Kingdom. I mean, look, I know it's possible to make mistakes. I mess up from time to time in my videos too. But when this is your main argument, when everything hinges on what you're saying, you should get the basic facts right. But these are good illustrations of the weakness of the approach of looking at ancient artifacts exclusively from the perspective of modern engineering without informing oneself of archaeological science and historical context. If you want to show people that archaeologists have it wrong about what was possible during the Copper Age, make sure you use examples that archaeologists date to the Copper Age.
Tanis itself must have been a mighty and awe-inspiring megalithic triumph in Antiquity, a true playground of the giants. The remnants of some just massive statues can still be found here. You have to use your imagination to picture the scale of some of these works, so try to do just that, working from the size of just this one big toe, which is carved from granite. This statue would have been a single piece, likely of a figure either seated or perhaps even standing. In terms of sheer mass, these types of statues far exceed the boxes in the Serapeum. In terms of precision, analysis shows that they bury the theory that they were made by a Bronze Age culture using nothing but pounding stones and hand tools right into the ground.
All right, looks like he saved the best for last. Let's hear the results of the analysis.
At the temples of Luxor and Karnak in Upper Egypt, we find the best known examples of these giant precision statues. For the best technological analysis of the precision manufacturing techniques that must have been used to shape these behemoths, once again we turn to the work of Christopher Dunn. By analysing a huge array of photographs that he captured during several visits to the statues, Dunn has shown that some incredibly complex geometric engineering and precision manufacturing was involved in creating these statues. Not only that, but this plan was executed to perfection again and again.
You might be wondering, as I was when I first heard this, how depictions of people could be judged to be precise. Human faces and bodies are so varied and imprecise, right? Well, it's about the symmetry. You see, the ancient Egyptians were more interested in idealism than in realism, and UnchartedX is of the opinion that the symmetry is an indication of lost high technology. At least symmetry at a certain level.
We start this analysis with the hejets and the peshents, which are the elongated crowns that sit on top of these statues representing Upper and Lower Egypt, and several of these crowns have been detached from these statues. Dunn shows how they are the result of an extremely complex series of compound radial curves and spherical geometry that's been made into 3 dimensions, and then these precise shapes were repeated from crown to crown. There are no flat surfaces here. This is something far more challenging. Yet the smoothness and the consistency of the arcs in the shape are basically perfect, and they seem to be replicated exactly from one example to the next.
As you might guess, my response is, the Egyptians deserve praise for such fine work, and for being so consistent that someone like Ben can say, they seem to be replicated exactly.
To make these shapes, radial cuts need to be made in a fashion such that the radius stays consistent, but the center of the radius arm that's making the cut moves, and moves precisely in 3 dimensions. The crown appears perfectly symmetrical from side to side. If you take a photo lined up from the front, then reverse the image and lay it transparently down on the center line of the original image, the sides line up exactly, as Dunn shows here using this technique.
But seeming to be exact, and being exact, of course, are different things. I'm not familiar with how one measures the symmetry of a sculpture or what tools are employed to do that, but I wonder about the accuracy of the results a person might get from taking a photo without any sort of calibration. And we seem to be right back to the eye again in determining exactness. Dunn admits he just went to the site and took photos as straight as he could, according to his own judgment. Am I right to be skeptical? Does Dunn know the exact angle? Exactly what horizontal and vertical axis he is on? You can't measure precision imprecisely. And with imperfect original material, no matter how precise you get later on with your computer, you can't turn it into something precise. As they say, garbage in, garbage out.
The next time somebody scoffs at the idea of ancient high technology, who tells you that they think they know how this was done, that the ancients just applied time, patience, and chisels to the problem, ask them to replicate one of these crowns. It would be quite the challenge, even at 1/50th of the scale, to create something that exhibits the same precision, dimensions, and proportions of the original object. Ask them to do it in granite, by hand, using the tools found in the archaeological record, and I think we'd start to see some of the truth behind what we're really looking at here.
Is Ben aware that becoming a skilled craftsperson takes years of training and diligent practice? He must be. So how does he expect an amateur to be able to achieve something of that caliber without devoting 20 years to learning the craft and another 10 to make it? I hear this kind of argument a lot. Unless I see someone today making the exact same thing with the exact same tools, I won't believe it. All that isn't even necessary to show that it could be done. All that needs to be shown is whether the stone can be cut and shaped using the technology available to the ancient people. That's it. If it can, then any artist devoted enough can make something both beautiful and precise. In my True Purpose of the Pyramids video, I suggested to those who argued that it was once a power plant that they make a model of it to demonstrate how it worked. I didn't ask anyone to create an actual pyramid power plant because I realized that isn't necessary to demonstrate if something is possible. Similarly here, if it can be demonstrated on a smaller scale that stoneworking of this sort is possible, and we use the science of physics to determine mathematically what's possible, then we can extrapolate that it could have been accomplished with larger objects too.
This truth becomes only more astounding when a similar analysis is made to the faces of the Ramses statues. Here, once again, we see evidence for advanced three-dimensional geometric precision and remarkable symmetry made into huge granite objects that has been replicated over and over again. These statues, be those at Luxor, Karnak, or at the Ramesseum, appear to have all been cut and shaped to the same plan, to the same face, and then that work was carried out with an absolutely mechanical degree of precision. Chris Dunn has derived many different aspects of complex geometry in the construction of the faces, and he's shown that core sacred geometry and mathematical principles like the Fibonacci sequence, Pythagorean right-angled triangles, the golden ratio, and even the flower of life are reflected in the stone. Varying degrees of radial cuts were consistently made into the granite, and the axes of these cuts were blended to form compound surfaces that curve in 3 dimensions, making up the features of the face. These complex surfaces were precisely inversed and replicated from side to side. These faces are symmetrical, and the implications of this when applied to the manufacturing techniques used to make them are, quite frankly, staggering.
Christopher Dunn took his photographs using a camera which he moved by hand while panning in action mode around the statue, doing his best to keep Ramses' nose in the center of the viewfinder. Dunn admits that there was error in the orientation of his photos, so what did he do? He adjusted the photos in post-production, he says, using the shadow he saw around the bottom of Ramses' face as a guideline. By bringing the shadow into symmetry, he was amazed to find Ramses' face perfectly symmetrical. Now, I'm sure you realize the problem with that approach. Setting aside the issue of where the sun was located at that time of day, if you align the camera to achieve symmetry in the shadows, of course you can't then claim to have discovered symmetry by a neutral standard. That's fudging. Anyway, Dunn admits that slight variations in the camera angle can yield different results, and that the limitations of the procedure he used requires new measurements be taken with metrology equipment. Dunn's exact words are, "Without specialized equipment and special permission, it's impossible to achieve the laboratory-type analysis that I am convinced must be achieved in order to quantify exactly the accuracy to which these statues are crafted." So this is another case of drawing conclusions before the evidence is complete. All parties are agreed that the statues are symmetrical. The difference of opinion is whether the statues are so precise that the Egyptians would not have been able to make them. So far, no evidence has been provided to suggest otherwise. Dunn claims the amount of error can be no thicker than a thumbnail. Even if it was confirmed that he is correct in that assumption, which he may very well not be, there is nothing remarkable about ancient Egyptians being able to achieve accuracy on that level. It's impressive, but nowhere near impossible. Give the people some credit for Ptah's sake.
How could these have been made? The only way we can accurately and consistently create such complex surfaces today is with computer design and mechanical guidance in CNC machines that are basically milling machines that operate in 3 dimensions. How does this process work for something that is 40, 60, or 90 feet tall and weighs anywhere between 400 and 1,000 tons and is made from granite?
Egyptian art suggests they use scaffolding to get up that high. And how much the granite weighs is only an issue for transport, not for precision artwork.
I've heard many people suggest that because sculptors like Michelangelo could create artwork as incredible as the statue of David, then surely this is proof that artists can do anything. I've been to Florence and I've seen David. It's a profoundly beautiful achievement, but it's just not the same thing as the mechanical precision and symmetry reflected in the Ramses statues. David is utterly and emotionally human in its lack of symmetry, whereas Ramses appears to be so inhuman or perhaps beyond human because of its symmetry. And what's more, it's made out of granite. This substance is orders of magnitude more difficult to work in than marble, and modern sculptors understand this.
I have a question for you. Which is more difficult, to create a face in art that more accurately represents an actual human face, or to create a face that is the same on each side? Answer, the former. Give a little kid a protractor and they'll draw you a symmetrical face. Ask for a face that looks exactly like their mom, and you won't be able to get it. Such accomplishment comes from years of training and practice. So all this talk about symmetrical faces being more advanced is silly.
Chris Dunn contacted contemporary sculptor Mike Leckey, whose beautiful touch in marble resulted in pieces like this one, called Bather in Marble. I'm quoting now from a letter from Mike Leckey sent to Chris Dunn on the subject of the Ramses statues. Quote, "Dear Chris, thank you for this opportunity. I've been interested in Egypt and its sculpture since I was a child. As a stone sculptor, I can say that the granite of the Ramses head and figures is an extremely hard stone, and I believe tools much more durable than hardened copper chisels must have been used in the carving process."
I'm trying to figure out why Dunn asked Leckey if those statues could be made with copper chisels when they're products of the New Kingdom. During Ramses' reign, iron was already being imported into Egypt from Anatolia. Leckey continues,
"It would be necessary for me to upgrade my normal tools to carve such granite. My modern diamond blades and grinding points would be worn out before the head was started. The ancient carvers must have had advanced technology. Although the ancient Egyptians had stone chisels and hammers, which could cut the extremely hard granite, even with an army of disposable labour, completing 4 large sculptures exactly alike with hand tools would take more time than we can conceive of as possible. Modern man with all his modern tools would be challenged to finish one Ramses in a generous timeline. Creating 4 of them as large as they are, all the same, seems almost impossible."
Leckey says that stone chisels and hammers would be capable of cutting the granite. And of course, if you watched my last video, you would be aware that granite stoneworking was a profession that existed in Egypt since the early dynastic period. His only issue really is that he thinks it would take too long. This, of course, I also talked about in my last video. But suffice it to say, the length of time can easily be calculated mathematically. So show us some numbers. Numbers are more reliable than the imagination of a sculptor who has never made anything on that level or with those tools.
So, what can we infer from all this? It should be clear at this point that there is utterly no chance these statues, the columns, or the precision boxes and vases could have been so precisely and repeatedly fabricated by a Bronze Age culture using the tools that are found in the archaeological record.
But they could have been made by a Stone Age culture using the tools that are found in the archaeological record?
An analysis of these objects isn't proof in and of itself for a lost civilization that predates the dynastic Egyptians, but it is pretty solid proof that they required forms of high technology to manufacture, regardless of whether or not we found any tools like that. At the same time, we need to balance this conclusion against the fact that we know an awful lot about the dynastic Egyptians. We know about their capabilities, about their daily lives, and we have their tools in the archaeological record, and none of it explains the manufacturing of these precision objects. Despite this, our academics insist that they built everything we see in ancient Egypt, but you just can't have this both ways.
Some of you may have caught the double standard he's using here. On the one hand, he says our knowledge about the daily lives and capabilities of the Egyptians of the Bronze Age, and their tools left in the archaeological record, is solid proof that they didn't make the objects. He even says there's utterly no chance that the Egyptians made them. But, on the other hand, our knowledge about the daily lives and capabilities of the people of the Stone Age, and their tools left in the archaeological record, is in no way solid proof that they didn't make the objects. There's a good chance that people living during the Stone Age made them. If you're going to make an argument against a certain proposition, you can't then make an exception to that same argument on behalf of your own proposition.
Either we're completely, woefully incorrect about the capabilities and the tools of the early dynastic Egyptians, and they did in fact have advanced capabilities that rival our own, and they were able to make these precision objects. Or we're wrong in saying that they created them at all. To insist that both statements are true, that the dynastic Egyptians both made all of these objects and did so with the primitive tools of the Bronze Age, is logically inconsistent.
But the logical inconsistency only exists if someone can demonstrate that the tools and tech they had were incapable of the job, which you have not done.
Yet this contradiction is exactly the ground that our mainstream academic Egyptologists and archaeologists choose to occupy. Why do you think they don't want to discuss or investigate the nature of precision and technology evident in the manufacturing of these artifacts?
Well, the very fact that I am engaging with you shows that some mainstream academics are willing to discuss. One of the main reasons why a lot of them don't choose to, and no one should expect that every academic in the field ought to engage with him, is because they don't think people propounding new ideas without having yet obtained the evidence needed to support it, and in this very video we can see that in your admission that measurements still need to be taken, are worth answering. Why should they engage with half-baked ideas? It makes more sense to wait until an argument is complete before addressing its pros and cons. Why would you go up to some expert in a field and say, "Hey, I have a great hypothesis. Will you research it for me?" Do the research yourself. If you need to, enter the profession so that you can obtain the knowledge and resources you might need to do it. But it's the height of hubris to think that academics should drop what they want to work on your stuff.
Almost every expert who investigates these precision objects, the engineers, stonemasons, the architects, they all recognize the achievement they represent, and they inherently understand just how far out of a Bronze Age culture's reach that they are.
Correction. Almost every expert that you know of. You appear to be listening only to the testimonies of people who take the same side on this issue. Try reading testimonies of engineers other than Chris Dunn, geologists other than Robert Schoch, architects other than Randall Carson, and archaeologists other than Sir Flinders Petrie. The latter disagrees with you anyway. Widen out. There's so much more to know on these subjects. Anyway, the rest of his video is repetition of the same points, so we'll bring this to a close. If you like videos of this kind, please let me know by giving it a thumbs up. And don't forget to subscribe if you haven't already. I would love to hear your thoughts on all this. Leave your comments and questions below. And thank you for listening all the way to the end. These videos are 100% community supported. If you'd like to help me keep this channel alive, the best way to do that is by becoming a patron for as little as $2 a month over at patreon.com/World of Antiquity. But even small things like watching videos all the way through, including the ads, helps a lot. We'll see you next time.